A surface condenser operating at a pressure of 24 kilonewton per meter square condenses 1.8 ton of what? Of steam per hour. The steam enters the condenser while the dryness fraction of 0.98 and is condensed but not undercooled. Cooling water enters the condenser at a temperature of 21 degrees Celsius and leaves at 57 degrees Celsius. So determine the flow rate of the cooling water. So you have to take note of this. After figure out the data, we know our pressure, which is what? Which is 24, and we are going to convert it, and it will be now become 0.24 bar. So if I convert this 24 kilonewton per meter square, it will become 0.24 bar, and therefore I am to determine the flow rate of the cooling water. But before then, I'm going to find from the steam table 0.24 bar what will be the H of F and what will be the H of FG. So let's see the steam table. So from the steam table, we are given 24 kilonewton per meter square. After converting it to bar, it will become 0.24. So I will just come across, this is P, the pressure which is in bar. So I will first take a look and see where is 0.24. So this is 0.24. So I will say this is 0.24. This is my H of F, so I will come across H of F 0.24242424. Yes, I will get 268. So 268 will be my H of F, and therefore the H of F of G will be 2348. So this is what? This is the H of what? H of FG, which is 2348, and the H of F, which is 268. So this is how you can find the steam table, and you have to take note that your steam table maybe might not be the same as my own, so care must be taken, but just follow the procedure. So as you can see the steam table, from the steam table the H of F, it is the same thing as what? As 268 kilojoule per kg, and also the H of F of G, which is 2348 kg per kg also. So from now on, I will say my H1, let me call this H1, it is equals to H of F plus what? Plus XH of F FG. So this will now be equal to what will be my H of F, which is 268, and also plus my dryness fraction, which is 0.98, and also multiply by H of F of G, which is 2348. So what will be the H1? So at the end, H1 will now be equals to, if I say 268 0.98 multiplied by 2348. So at the end, my H1 will now be 2569.04 kilojoule per kg. So since the condensate leaves as what? As the saturated water, so therefore the H2 will now be equals to actually HF. So for now, H2 will now be equals to 268 kilojoule per kg, kilojoule per kg. So this is my what? This is my new H2, and this is what? This is my H1. The reason why H2 it is equals HF is that since the condensate leaves as what? Leaves as saturated water. So let me have some space. So now at the end, my Q will now be equals to H1 minus H2. So what will be my H1? This is my H1. So I will now say 2569.04 subtracted by 268, which is my H2. So at the end, the Q will now be equals to 2301.04 kilojoule per kg. So the extent of finding H1 and H2 is because I am going to find the value of what? Of Q. So the next thing that I'm going to do is that I am going to find the total heat removed per watt per hour. But let me have some space. The total heat that is removed per hour, it is the same thing as Q, which is equals to the ms multiplied by what? Multiplied by Q, and this is the same thing as what will be the value of what? Of my ms. It is the same thing as 1.8 tons. So if I am to convert it, it will now become what? It will now become 1800. Which is what? Which is, I will convert the ton to what? To kg. So therefore, it will now become 1800 kg per hour multiplied by the value of Q that I find, which is 2301.04. So therefore, at the end, my Q will now be equals to 4.141 times 10 to the power of what? Of 6 kg per watt. Okay, sorry, kilojoule per watt per hour. So therefore, I will say this will be the MW, which is the mass of what? Mass of the water. And I will say multiplied by Cp and multiplied by delta T. T2 minus what? Minus T1. But I need some space. So as I said before, the value of Cp we are going to use 4.18 what? 4.187. So I'm looking for the MW. Whenever if I say that, you have to take note that the first thing, the delta T, it is the same thing as T2 minus T1 as I write from the formula. So I will say T2, which is 57. This is T2 and this is T1. So I will say minus 21 and it will now be equals to what? 36. So the next thing that I'm going to do here is that if I make the MW as the subject of the formula, I will just divide both sides by Cp and this delta T. And this Cp and this delta T will what? Will cancel each other and I will left with only this, but I will divide Cp delta T in this denominator of what? Of this Q. So I'll now say the MW, it is the same thing as value of my Q, which is 4.141 times 10 to the power of what? Of 6 divided by the M divided by the value of Cp and delta what? And delta T. So it is the same thing as 150.732. This is point. So let me see what should I go into get. I say 4.141 times 6 divided by 150. So at the end, I'll get 274. Okay, let me have some space first. At the end, I will get 27,478.385, and it will now be equals to 2.74 times 10 to the power of 4 kilojoule per watt per hour. So therefore, this is a flow rate that is gained by what? By the cooling water.